Following on from our previous video, we got to this stage here where we need to consider our sheet of paper going along this diagonal line. So this diagonal line. So our vertical sheet of paper looks something like this. We need to figure out what the sheet of paper will look like when it intersects with the surface itself. So this is our vertical sheet of paper here. So when x equals 1, let me just illustrate this by drawing a line like this. So when x equals 1, it will look like this. But not to scale, okay? So when x equals 2, it will look something like this. When x equals 3, it will look something like this, all the way up to 10. All the way up to 10. So dot 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 all the way up to 10. Bear in mind that this diagonal length here is this length here, and this diagonal length here is longer than x from 0 to 1, because the hypotenuse is bigger than the, let's call it the adjacent, because so this is like a new scale. Along here is from 0 to 10, x equals from 0 to 10. This is a new scale because we are going along the diagonal, so let's just call it S. So we need to figure out what this sheet of paper will look like when it intersects with the surface. So to do that, along this line here, y will always be this thing here. So let's put this into the y, and then put this into the y. Then the surface, then this thing here will look like this. And then if you tidy that up, it will look like this. So now we can figure out what our line will look like on our sheet of paper. When it's small, it wants to do this straight line. When it's big, it wants to do a negative quadratic. So looking at our sheet of paper, when x equals 0, it wants to have an intercept of, let's just imagine, negative 58 here. A gradient of 20, so it's really steep. And then when x is big, it wants to do a negative quadratic. So our sheet of paper will look something like this. Our sheet of paper will look something like this. Will look something like this. So we can see that there's a turning point here, and it seems quite high. So let's try and figure out this turning point. So looking at our line here, we need to find that turning point. We need to find this turning point. So looking at our line, differentiate it, look at the gradient. So when you differentiate it, it will then give you this thing here. When will the gradient be 0? So set it to 0. So x equals 5. It will be, the turning point occurs when x equals 5. So what that means is this. Our line graph looks something like this. Let me improve on that. So x equals 5. Remember, this is a new scale. It's not x. X is going along here. This sheet of paper is going along the diagonal, so it's a new scale. Let's just call it S. We don't really care about it. But when x equals 5, that's when the turning point occurs. So what that means is going along here, you're in the S axis. Let's just call it S. You're working in the diagonal line here. But the turning point occurs when x equals 5. So x equals 5. So at the back of your mind, imagine this is x equals 5. It occurs when x equals 5. But this is our scale is a weird scale. We're just going to call it S. It has nothing to do with x. But the turning point occurs when x equals 5. But it turns out to be right dead on the center of our sheet of paper anyway. So the turning point occurs when x equals 5. We need to find the height. So we need to put it into the function. So hang on. So we know the turning point occurs when x equals 5. We need to know the elevation. We need to know the height. So we need to put into the function. So when x equals 5, so we need to put 5 into the x. what is y when x equals 5? Well, what is y when x equals 5? Hang on. What is y when x equals 5? What is y when x equals 5? Well, put 5 into here, and then it turns out that y equals 5. So to find out the turning point, to find the turning point, we need to put 5 into the function. We need to put 5 into the function. But earlier we said y equals minus 10x. So y, when x equals 5, y happens to be 5 as well. So put that into this whole thing here, and it should be negative 8. So the elevation here is actually negative 8. So what that means is we've drawn the graph badly earlier. It should look something like this. Intercept of negative 58, and the elevation is actually something like this at negative 8. So yeah, the elevation is negative 8. Well, anyway, hang on. So we know that that this point here has an elevation of negative 8. Now let's consider when x equals 0. So let's look at this point here. So hang on, our graph looks something like this. Bear with me. Our graph looks something like this on this sheet of paper here, because an elevation of negative 8. This is negative 58, I think. So we need to consider this point here and this point here when x equals 10 and x equals 0. We need to consider these two. Okay, so going back down here. Going back down here, we need to consider when x equals 0. When x equals 0, remember, when x equals 0, y will be 10. So that's this 10 here. Put it into the function, it will be negative 58. Now we need to consider when x equals 10. Well, when x equals 10, y will be 0. So that's this thing here. Well, if you put that into the function, the elevation would be negative 58. So so now we've got everything. Our sheet of paper here, our sheet of paper earlier looked something like this. It looks something like this. Elevation of negative 8. That's this point here. Elevation negative 8. When x is 0, the elevation would be negative 58. When x equals 10, remember we are considering this diagonal line. When x equals 10, the elevation would be negative 58. So overall, in the previous video we worked out all these elevations here. In this video we looked at the diagonal one. Well, if you look at this, here it has an elevation of 10, here it has an elevation of 6, elevation of 2, elevation of negative, elevation of negative, elevation of 6. So the highest point is when you have an elevation of 10. That occurs right here, which we looked at in the previous video. I think it was as the coordinates of 2, 2. So the right here has an elevation of 10. Here it has an elevation of 2, elevation of 6, elevation of negative. So this is your max. This is your absolute minimum, negative 58. And there's another one over here. So this is your absolute minimum, absolute maximum for the region in question, which is this triangle here. So in conclusion, your maximum is 10, minimum negative 58, and it occurs at 10, 0 here. Well, anyway, this is the conclusion. Okay, so if you look at this, you can see that, well, I hope you can see that. The maximum occurs right here, minimum.